Alright guys, so what I'm going to do is I'm going to go over the 3.0 practice problems 1 through 3. You're still going to need to do the remaining problems 4 through 6 on your own. But I'm going to show you how practice problems 1 through 3 work. So the first one is talking about a bouncy ball. It says determine the volume of a rubber ball that has a mass of 80 grams and a density of 1.10 grams per centimeter cubed. So what we're going to do, as we always do, is we're going to put down D equals, M equals, and B equals. Okay? Then we're going to look up at our problem, and we're going to see what we have. So in this problem it says determine the volume. So that determine, that's our little context clue to let us know that that's a question mark. Determine means question mark, right? And it's saying determine the volume. So our question mark is going to be by the volume. Okay? So we're looking for the volume. That word determine means to find. Okay? So then it says of a rubber ball that has a mass of 80 grams. So it straight up tells us our mass is 80 grams. And its density is 1.10 grams per centimeter cubed. Okay? So we've got density and we have mass. We're looking for volume. So what I'm going to do is I'm going to set this up like a unit conversion. We're given mass and we want to convert it to our volume. So we're going to use density to help us with that conversion. So the first thing I'm going to do is I'm going to put 80 grams. I'm going to write that down. So 80.0 grams. Make sure I'm avoiding that dead spot. Okay? And I want to get rid of grams. So I'm going to do times the line, just like we did with all of our unit conversions for dimensional analysis. And if I want to get rid of grams, the place that I'm going to put my grams is on the bottom. So I want grams to go away. And what I'm hoping to get to and what I'm trying to solve for is my volume. So I'm going to be looking for volume, which is going to be in milliliters. Okay? Lies, it's going to be in cubic centimeters, because that's what the density is given me. To be honest, milliliters and cubic centimeters are the same thing. And so the next thing I'm going to do is I got rid of my grams. I'm going to cubic centimeters. So I'm going to look at my density, and I'm going to use that as a unit conversion. What this really is saying is that for every 1 centimeter cubed, so for every 1 centimeter cubed, I have 1.10 grams. Okay? What this really means is that 1 centimeter cubed weighs, or has a mass, of 1.1 grams. So I'm going to put that right here as my unit conversions. The grams are going to go away, right? Grams divided by grams. So here's how we put it in the calculator. So I know that we had some struggles with that a little bit. So we're going to put 80. So we type 80, and then we're going to put times, and then we're going to type 1, and then this line means divided by. So we're going to do divided by, and then we're going to put 1.1, and we're going to hit enter. And when we do, we're going to get a density of 72.7272, repeating over and over again. Okay? So how many of these do we actually have to write down for our answer? So I'm going to come back up to my original problem, and I can see 1, 2, 3 significant figures. That 0 counts because the decimal is there. And then when I look at 80, so the 8 counts, it's a non-zero number, and both of these zeros count because of the decimal. So both of our starting values have 3 significant figures, so our answer should also have 3 significant figures. So I'm going to take the first number, the second number, and the third, and cut it off right there. So my first 3 numbers, the 2 tells me I leave my 7 alone. So my answer is going to be 72.7. And then my units, my grams went away, so I'm left with just my cubic centimeters. So the volume is equal to 72.7 cubic centimeters. So that's problem number 1. All right, so now we're going to do problem number 2. So problem number 2, we're going to start off exactly the same way. We're going to write down what we know, right? So density equals mass equals volume. So we start our problem out just like we do with all the others. I'm going to read through the problem, try and figure out what we're solving for and what information we're given. So it says, what is the mass? So what is the? That's our context clue that means question mark, and it's referring to the mass. So our question mark this time is going to be by mass. okay, of 28.0 centimeter cube block. So centimeters cubed, that's a volume. So I know that I have a volume of 28.0 centimeters cubed of aluminum if the density, so it tells us our density is 2.7 grams per centimeter cubed. So I'm looking for my mass. So I'm going to set this up just like a unit conversion like we did with our previous problem. And to do that, I'm going to start with my volume. So my volume is 28.0 centimeters cubed. Okay, so 28.0 centimeters cubed. And I want to get rid of those centimeters cubed, so I'm going to do times in a line and set up my ratio. Because I want to get rid of centimeters cubed, I have to put it opposite, so on the bottom. So centimeters cubed, so centimeters cubed divided by centimeters cubed, so that's going to make that unit go away. And I'm trying to get to mass. Mass is in grams, so I'm going to put grams on top. So now I'm going to come over to my density and use that as my unit conversion. Okay, so 2.7 grams is equal to 1 centimeter cubed. That's what density really means. So 1 centimeter cubed has a mass of 2.7 grams. So I'm going to put a 1 next to my centimeters cubed, right? 1 centimeter cubed. And then it equals 2.7 grams. So I'm going to put that on top. So now my centimeters are going to go away, and I'm going to be left with grams. And so when I type this into my calculator, I'm going to be typing 28, right? 28 times 2.7 divided by 1. And if you know better, 1 is going to cancel out. So it's really 28 times 2.7. So 28 times 2.7 divided by 1, hit enter, and I get 75.6, and that's going to be grams, because my centimeters cubed went away, so that is my final mass, 75.6 grams. Alright, so we're going to do our last problem. It says determine the mass of Earth. So our context clue, our question mark word, determine, is referring to our mass. So we're going to start just like we always have with our D equals, our N equals, and our V equals. So we have those three things. And right off the bat, it tells us that we're going to determine the mass. So determine means to find, right? So we're trying to find the mass of Earth. So this is going to be a big number, right? To find the mass of Earth. And then it says we want to find the mass of Earth in pounds. So we're going to have to eventually convert an answer to pounds. If it's volume, so it gives us a volume, is really big. It's 1.83 times 10 to the 27 centimeters cubed. Okay, so that's a really, really, really big volume. Okay, and then it says its density is 5.51 grams per centimeter cubed. All right, so we're going to find the mass. Well, right now we've got centimeters cubed and we've got grams, so our answer is going to come out in grams. We're going to have to do some converting after we get our answer. But we're going to start out by taking our volume and we're going to convert it to mass using our density as our conversion factor. So I'm going to take my volume, which is 1 point, and I want to make sure I'm not going to hit the dead spot, and I definitely am. So I'm going to come over here. So I'm going to take 1.83 times 10 to the 27th, and that is centimeters cubed. I'm going to do times in a line, and I'm going to set up my ratio. So I want centimeters cubed to go away, so I'm going to put centimeters cubed down the bottom, and I'm trying to get to grams, so I'm going to put grams on top. And I'm going to come over to my density, and what my density says is that I've got 5.51 grams. So 5.51 grams for every 1 cubic centimeter. So we're going to have to type this into our calculator, and I know that we have struggles with using scientific notation. So the way you're going to type this into the calculator is you're going to type 1.83, and then the buttons that you're going to hit on your calculator is you're going to use the second button, which is right here, And then you're going to use the capital E button, which is right here above the number 7. Okay? So you're going to type 1.83 second E, and then that's going to be, so you'll have a capital E on your screen, 27. So that will give you the whole number. And I don't know if you can see it on my calculator. Maybe you can without the glare. You can see that capital E there. And then I'm going to hit times, and then I got 5.51 divided by 1, and then I'm going to hit enter. So I'm going to take my number times 5.51 divided by 1, and I'm going to get this as my answer. 1.00833 times 10 to the 28, and we got rid of centimeters cubed, and this is grams. But that's not what we want. The problem says we want our answer not in grams, but in pounds. So it says how many pounds, okay? So we're gonna have to take this answer in grams, and we're gonna have to convert it to pounds. And this is something that we've already spent lots of time doing in class. So I'm gonna take my answer, my 1.00833 times 10 to the 28 grams, okay? And I want grams to go away and I want to get to pounds. So luckily I have some conversion factors up here. So the first thing I'm going to do is times in a line. I want grams to go away and I want to get to pounds. So I can go from grams to kilograms by taking 1,000 on the bottom and 1 kilogram on top, right? I want to get rid of grams, let's go to the bottom. I want to get to kilograms, so I'm going to put that on top. Then the next thing that I want to do is grams will be gone, but I have kilograms and I need to get that to pounds. So the next thing I'm going to do is I'm going to look over here and I'm going to get rid of kilograms, so I'm going to put kilograms on the bottom, and I want to go to pounds, so I'm going to put pounds LBS on top. And what that is for every 1 kilogram, so 1 kilogram is equal to 2.2 pounds. So I'm going to type this into my calculator. So hopefully you have your answer in there from before saved. Otherwise, you're going to type 1.00833, and then you're going to hit second E to bring up that capital E, and then you're going to type 28. Then you're going to do times 1 divided by 1,000. So 1 divided by 1,000. And then we come to the next times symbol, so we're going to hit times again. And now we've got 2.2 divided by 1. And now we're going to hit enter. So when we do that, our calculator is going to spit out 2.218326 times 10 to the 25th. We don't need all those numbers. We're going to come up to our original problem, and I'm going to see 1, 2, 3 significant figures in that number. I see 1, 2, 3 significant figures in that number. So I'm going to round this to 3 significant figures. So I'm going to keep the 2 and the 2 and the 1. I'm going to put my number off right here. Because there's an 8 right here, I'm going to round my 1 up to a 2. So my answer is going to become 2.22 times 10 to the 25th pounds, LBS. So there's my final answer. Nice and rounded. So 2.22 times 10 to the 25th pounds. That's how much the planet Earth weighs. That's a lot. Okay? Thanks, guys.